Everybody, welcome to another con support video. This one's on right triangle side lengths. Let's go. He says, which side lengths form a right triangle? Choose all the answers that apply. So remember, when you're checking whether or not these are right triangle side lengths, you have to make sure that they follow the rule for Pythagorean's theorem. A squared plus b squared is equal to c squared, right? Where the two legs, the two shorter sides, squared and added together is always equal to the hypotenuse, the longest side, squared. All right. If this is true, then it's a right triangle. It's that simple. So when you're looking at these ones here, right, all you're really checking is for A, right? You're investigating A. And you're saying, is the longest side of the hypotenuse squared equal to the two smaller sides squared and added together? Right? So in this case, is 9 squared plus 12 squared equal to 15 squared? And that would be 81 plus 144. And is that equal to 225, right? Well, 81 plus 144 is going to be 140 plus 80, which is going to be 220. And then 1 plus 4 is 5. So yeah, 225 does in fact equal 225. So basically, is 9, 12, 15 a right triangle? The answer is yes, right? For the next one, it's got 2, 6, and the square root of 38. Now, when we're looking at this one here for B, it's got 2, 6, and the square root of 38. Well, the square root of 38 is somewhere between 36 and basically 49. So somewhere between 6 and 7. So it's bigger than 6. So that would be your hypotenuse. So what you're looking at here is 2 squared plus 6 squared. Is that equal to the square root of 38 squared? Now, the square root of 38 squared is pretty straightforward. That's going to be 38. Remember, a square undoes the square root. And then 2 squared is 4, and 6 squared is 36. So it's 4 plus 36 equal to 38, and the answer is no, it's not. So this one's a no. It's not going to work. And then we're looking at investigating C. You're going to ask if is 3, 9, and square root of 91 going to work? Square root of 91 is between basically 10 times 10 is 100, right? 9 times 9 is 81. So it's between 9 and 10. So it's bigger than 9. So this is your hypotenuse. So now we're looking at 3 squared plus 9 squared. Is that equal to the square root of 91 squared? Well, the square root of 91 is going to be, squared is going to be 91. And then 3 squared is going to be 27. And 9 squared is going to be 81. So is 27 plus 81 equal to 91? No, it's not. So this is also a no. So there's only one that works, and that's A. A is the only one that's a right triangle relationship. So that's what you put. Not C, not B, just A. Okay. Now, before I get into this next one, I want to remind you guys of some of the known right triangles, right, that you can be looking for real quick to make things easy for yourself. So the known right triangles, the ones that are like really common, well used right triangles, are the following. You're looking for 3, 4, 5 or a multiple thereof. You're looking for 5, 12, 13 or a multiple thereof. You're looking for 7, 24, 25 or a multiple thereof. You're looking for 8, 15, 17 or a multiple thereof. Or if it's an isosceles right triangle, x, x, and then x times the square root of 2. All right? So these are your known right triangles. So let's take a look and see if we see any of those here. I see 7, 24, 25. So that definitely is going to work. Okay? I don't really know about A and C. Okay, so let's investigate C first. That's a little easier. So if I were to investigate C, let's do a new little investigation here. Well, let's do A, actually. Let's do square root of 290. It looks like it's bigger than 13 because 13 squared is going to be 169, so definitely not 290. So that's going to be, it doesn't look to me like a right triangle, just to be honest. But let's investigate it. So if it is a right triangle, it would be 11 squared plus 13 squared is equal to the square root of 290 squared. And that would be 121 plus 1, 12 squared is 144, 13 squared is 169. So that's going to be 169. And if you ever forget what your squares are, if you haven't memorized them yet, then it would be 13 times 13, right? Which is, like you see, 169. And then the square root of 290 squared is going to be just 290, right? is this going to work out? Let's find out. So 69 plus 21, that's going to be 70 plus 20, which is 90, and then 100 plus 100 is 200. So I was wrong. It is a right triangle. So 290 does equal right triangle. My instinct said no, but you know what? The numbers say yes. So it is a right triangle. For the 2, 5, and 7, let's look at that one. So 2, 5, and 7 is something we're going to investigate. So 2 squared plus 5 squared, is that equal to 7 squared? So that's going to be 4 plus 25. Is that equal to 49? And obviously that's not going to work because that's 29 is equal to 49. And last time I checked, 29 is not equal to 49, right? So that's a no. So the only one that work are the first two. Okay. All right, I think you guys get the hang of it. Let me pause and clean this up a little bit. All right, now that I got a little set up here for you, let's first check and see if these are known right triangles, right? So 2.5, 6, and 6.5. If you double 2.5, you get 5. If you double 6, you get 12. If you double 6.5, you get 13. So guess what? That's your 5, 12, 13 known right triangle. So that's going to work. The 3, 6 square root of 45, I don't know for sure. And so same with the 4, 8 square root of 80. So let's take a look at those ones a little more carefully. Now the square root of 45 is somewhere between 36 and 49, so it's bigger than 6. That's going to be the hypotenuse. The square root of 80 is somewhere between, it looks like 64 and 81, closer to 81. So it's closer to 9 than 8. So it's going to definitely bigger than 8. So this is our hypotenuse. So these are in order. It seems like they always put them in order from to the two legs and then the hypotenuse. I think that's what they're kind of doing consistently. So it looks like it's least to greatest order always. All right, so anyways, let's take a look at A. So when we're looking at A, it's going to be 3 squared plus 6 squared. So 3 squared plus 6 squared, is that in fact equal to square root of 45 squared? Well, 3 squared is 9 and 6 squared is 36. Is 9 plus 36 equal to 45? The answer is yes. So then you would say that this one is a winner, right? Bing, 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 good job. For this one, it's going to be investigated. It says 4, 8, and square root of 80, so that'll be 4 squared plus the 8 squared should be equal to, hopefully, the square root of 80 squared. Now, 4 squared is 16, and 8 squared is 64, and does that add up to 80? The answer is yes. So this is also a right triangle. So actually, all three of these are right triangles. All right, let's clean this up for you, and then we'll start again. Okay, so let's do this one. It says, let's do this in blue. All right. It says, which side lengths form a right triangle? Same thing. It's going to be in least to greatest order if everything's been consistent like last time. You guys look at this one. It says 8, 15, 17. That's one of the known ones that we talked about, right? So 8 squared plus 15 squared is definitely 17 squared. That's just one that you can memorize. It's 8 squared plus 15 squared should equal 17 squared, and it does. Looking at it, A and C, we got to investigate a little more carefully. I don't see anything that's a known right triangle there. This one makes me kind of think of a known right triangle of x squared root of 2. But with isosceles lengths like this, so whenever you have the two legs that are the same, technically the hypotenuse should be this length, square root of 2, and then times the square root of 2. And that looks like it might work actually, because the square root of 2 times the square root of 2 is something that you can rewrite as the square root of 2 times 2. And you guys don't really have that skill yet, but then you can see that that is the same as the square root of 4, which is, of course, 2. So this one is going to work. I'm going to prove it to you guys the more traditional way, not just using the pattern here, because I think that's going to be the way you probably would approach it. So if you did square root of 2 squared plus the square root of 2 squared, you should get 2 squared. And the square root of 2 squared is 2, and the square root of 2 squared is 2, and 2 to the second power is 4, so is 2 plus 2 equal to 4? Yes. So this one is a yes. So C, we can say, is successful. That is a right triangle. And then for A, we're going to check A and just investigate A here. And that's going to be 5 squared plus the square root of 8 squared is equal to 33 squared. Now, that does not look right to me at all. Just 33 squared is going to be huge, and these aren't going to get to be huge. So to me, I look at that and say no, but I'm going to prove it to you. So 5 squared is 25, and then square root of 8 squared is going to be 8. And that adds up to not 33 squared. That adds up to 33, right? Which is way smaller than 33 squared. What's 33 squared worth? Well, 33 times 33, obviously. That's 1,089. So is this true statement? No, it's not. So is this a right triangle? No, it's not, right? They just try to trick you by making you think you see the 33 and that's going to make it all work, and it doesn't work. It has to be that hypotenuse side squared. So that's it. That's how you guys do these problems, right? So if you happen to see one of the known right triangles or a multiple of the known right triangles, anything that's proportional to one of these, then you're golden. They're right triangles. If you don't see one of those known right triangles, then use a squared plus b squared equals c squared.